a car enters a circular curve of curvature, radius of curvature 0.4 kilometer at a constant speed of 83 kilometer per hour. If the friction between the road and the tires can support a centripetal acceleration of 1.25 meter per second squared. Now, in other words, that is the safest acceleration that the car can have. If the speed increases above this, the car will not be able to keep in that circular track. That is the meaning of that. Now, does the car negotiate the curve smoothly? Well, I think I need to change my argument a bit. Our aim is to find if this speed is a safe speed. Now, how do you know if that is a safe speed? Well, this is the maximum centripetal acceleration that the friction between the road and the tires can provide. You see, the frictional force cannot exceed this value. And therefore, we need to find out if this speed is a safe speed for that centripetal acceleration. Alright. Well, this is the speed of the car. That is 23.1 meter per second. And the centripetal acceleration that will be allowed by the force of friction. This is the safest centripetal acceleration. That is 1.25 meter per second squared. What is the equation for the centripetal acceleration? Centripetal acceleration is v squared over r. We know the radius. We are given the centripetal acceleration. Therefore, we can calculate the safe speed for that radius of curvature. And that's what we're going to do. So the radius of curvature of the curve is 400 meters. When the car negotiates a turn, it is the friction between the tires and the road that supplies the necessary centripetal force. Now, if v is the maximum safe speed for this curvature r, then the centripetal acceleration is v squared over r, where v is the safe speed for that particular curve. Therefore, v squared is the acceleration multiplied by the radius. The acceleration is 1.25 and the radius is 400 meters. And that is 500 meter per second squared. That is v squared. Therefore, what is v? V is 22.4 meter per second. It means the friction between the road and the tires will allow a maximum centripetal acceleration of 1.25 meter per second squared for this particular radius. And that means you can drive up to 22.4 meter per second safely on that curve. And what is the speed at the time? 23.1. Is this a safe speed? No. This is above the allowed safe speed. So you can actually be thrown away or you can skid, and that can be dangerous. Is that right? Now, every time you see a curve, you see a speed limit there. You are not allowed to go above that speed. That is the maximum safe speed for that curve. If you exceed that speed, you are then asking for a greater centripetal acceleration which may not be there. And if it is not there, you will not get the centripetal force to keep you in that circular track. So you will be thrown away from that circle. Since the actual speed of the car is greater than the safe speed, the car does not negotiate the curve smoothly. That is where you hear the screeching and howling of the car tire with the road. Okay, let's look at another problem. A 100-gram disc sits on a horizontally rotating turntable. The turntable makes 1 revolution each second. The disc is located 10 centimeters from the axis of rotation of the turntable. What is the frictional force acting on the disc? The disc will slide off the turntable if it is located at a distance larger than 16 centimeters from the axis of rotation. What is the coefficient of static friction? Well, this is a good problem. I want to think about this and see what are the given information and how we use the given information to solve this problem. Now, here I have the turntable. The turntable can be turned, and I'm going to place this disc on the turntable. Alright, now when the turntable turns, the disc is going in a circle. Now tell me, what is it that provides the centripetal force for it to go in a circle? And it fell off. Why did it fall off? Now, the centripetal force is provided by the friction. And the friction between these two is not increasing. If I increase the speed, you can see when the speed is small, it will not fall off. So the centripetal force mv squared by r is only small. You need only a small centripetal force now. But if I increase the speed a bar, it's fallen off. Well, so in this case, we can figure out the centripetal force, which is the friction between the disc and the turntable. And the centripetal force mv squared by r is that frictional force, is that right? And that is what we're going to use in solving this problem. What is the frictional force acting on the disc? The frictional force is the centripetal force. Alright, this is the disc which is rotating, and we place, well, this is the turntable, and we place a disc of mass m equal to 0.1 kilogram on the turntable, and the radius, the distance of the disc from the center of the turntable is 0.1 meter. So when the turntable goes around, this disc will rotate in a circle of radius 0.1 meter. So the turntable makes 1 revolution each second, means that it describes an angle of 2 pi radians in 1 second. That means that is the angular velocity. Is that right? If it goes round once in 1 second, 1 revolution in 1 second is 2 pi radians per second. That is the angular velocity. So omega equal to 2 pi radians per second. Can you calculate the centripetal force? The centripetal force, therefore, is F centripetal is mr omega squared, mass times centripetal acceleration. We have shown that the centripetal acceleration is r omega squared. Therefore, the centripetal force is mr omega squared. We know the mass, we know the radius, we know omega. Therefore, the centripetal force is 0.4 Newton. In order for that disc to sit there and go around the circle comfortably, there must be a minimum force of 0.4 Newton. In the absence of this centripetal force, the disc will move away towards the tangent. And where does the centripetal force come from? It comes from the friction between the disc and the turntable. Well, So that is the frictional force. In the B part, the disc will slide off the turntable if it is located at a radius larger than 16 centimeter. That means if you move the disc away from the center, the radius is increasing. Is that right? That's right. So what happens to the centripetal force? Well, the maximum frictional force on the disc when it is 16 centimeter from the center of the table is again mr omega squared, where the radius is now 0.16, and that will be 0.63 Newton. So that 0.163 Newton is the maximum centripetal force. What does that mean? Well, if the disc slides away at that radius, that means that is the maximum frictional force the disc and the turntable can provide. The frictional force cannot increase more than that. That means this 0.63 Newton is the force of limiting friction. And what is the normal force in that case? What is the force pressing the disc onto the turntable? The force pressing the disc onto the turntable is its weight. Now, its mass is 0.1 kilogram. Therefore, its weight will be 0.1 times 9.8, which is 0.98 Newton. So, we have now two important quantities. What are they? We now know that the maximum frictional force between the disc and the turntable is 0.63 Newton. And that is the force of limiting friction. And we know the normal force pressing the two surfaces together. If you know these two quantities, can you calculate the coefficient of static friction? The coefficient of static friction is the force of limiting friction divided by the normal force, or the force of limiting friction is mu s times Fn, or mu s equal to Fs over Fn. That will be 0.64. All right? Okay, let's now talk about